Saxon Algebra 2, Lesson 33. We have kind of a barely a two-parter. The first one, we're just going to review a little bit of information that you already know, and then we're going to jump into a little algebra topic. The first thing that I want to talk to you about are the major rules of algebra. We don't say this in so many words, but there are three major rules in algebra. We use them all the time. You're completely familiar with them, but I don't believe we've often talked about them as, oh, they're the major rules of algebra. So I want to do that today, so if someone says to you, hey, what are the major rules of algebra? You'll be like, oh, I've got this. This is easy. The first two, there are three of them. The first two apply to equations. And obviously that's a string of numbers and symbols that include an equal sign. And when you find one in your homework, it tells you to solve. Right? That's how you can tell what an equation is. The first of the major rules of algebra that relate to equations says that you can add or subtract any number to both sides of an equation. We do this all the time, right? That's what swimming is, right? We're adding or subtracting, and as long as you do it to both sides, you're fine. It's perfectly allowed. The other thing we do, this is the best friend go home move, we can multiply or divide any number and here comes the caveat, except 0, and I'm going to put a slashy through it so you know that's a number and not a letter, to both sides of the equation. And we do this all the time. Like I said, this is the best friend go home move, right? It's when your variable is being multiplied by something and you divide both sides to make it go away. That's allowed. The only problem is we can't use 0. We can't divide by a 0 because it'll blow up the kingdom, right? And we can't have that. It's already been blown up, so that ship has sailed. We don't multiply by 0 because if we do, that just wipes everything out, doesn't it? If we multiply both sides of an equation by 0, we change both sides to 0 and we just take all the value out of the equation. So that's the only caveat to the second rule, is we can multiply or divide any number as long as we do it to both sides, but not 0. Okay, those are the two major rules of algebra that apply to equations. We do that all the time. We've been doing it for years, right? This is not anything new. The third rule of algebra, it applies to expressions. Expressions are kind of, the opposite of equations, right? In an expression, there is no equal sign. And we're told to simplify. That's another way you can always tell you have an expression, is by John's instruction in the homework. This third rule is the one we're going to use a whole bunch today. It's called the Denominator, Numerator, same quantity rule. Oh my gosh, it's so long. And I know we say the bottom first, but that kind of is the way it should be. And this one says that you can, that's just the name of the rule. We don't really have, I don't even want to talk about the names to those. This one I wanted you to see the name of. And this says that we can multiply or divide any number except 0 to the top and bottom of a fraction. I'm not going to write of a fraction because I ran out of space. This is the one we're going to use today, so you'll see it in a minute. But we do this all the time anyway, right? When we're adding fractions, sometimes we have to adjust to make the denominators match, and we multiply the bottom and the top by the same number. That's this rule. You've been doing it for years, and you didn't even know. How smart are you? Okay, so, excuse me, I'm fumbling around with my pages. Let's turn to the second part of this lesson and do some complex fractions. Complex fractions are a perfect illustration of the third rule of algebra. They're not equations, they're expressions. There's no equal signs anywhere. And so we know that we're not able to reduce them to like an x equals something, but we can make them simpler and cuter looking, and that's called simplifying. 33.1, simplify. Ready? They're getting crazier. All right. The first thing to remember when you're writing down these problems is exaggerate the lines so that you can see which are the bigger lines and which are the smaller lines. We want to always go to the bottom. I think of going to my grandma's house, to the basement, and she had a creepy, scary cellar that was up right at the bottom of the stairs, but then when you walked around the corner, it was more finished. And that was where we slept when we went to her house, but you had to go through the creepy part first. So we have to go to the creepy part of the problem, down in the bottom. We want to use reciprocals to turn this into a 1, because if we have 1 in the denominator, our problems go away. So we're going to multiply this by the reciprocal, right? That's going to be beautiful. That's going to turn into AY over AY, and that's going to turn into a 1, and that's going to poof and explode and float away, and we don't have any denominators ever again. However, we also have to multiply the top, because that's the third rule of algebra. It says if you do it to the bottom, you have to do it to the top. Now, the other thing that's going on up top is that we have two separate fractions that aren't put together. That's not good. So we want to turn this into 1. So we look at the denominators and we find the LCM, and it equals xy, right? So we're going to have to multiply this one by x over x. Now those two match. So I'm going to rewrite this over here. I'm going to write x squared plus 4 over xy, right? Because there's the x squared plus the 4, and then this is xy and this is xy. I just rewrote the order. Now we're multiplying that, and I can't cancel anything this way, but look, these are being multiplied, so I can cancel that. So my final answer will be, this is on the top, x squared plus 4 over a times x. There we are, using our denominator, numerator, same quantity rule to solve problems. Okay, and we just have one more, and then we are done with lesson 33. Okay, this one looks a fair amount like our other one. We go to the basement, we see what are we going to do to fix this? Oh, right, multiply by the reciprocal, a plus m over x, and that's going to turn into a 1 and disappear. So all this is gone. However, if I multiply this times the bottom, I have to do the same thing on the top. Denominator, numerator, same quantity rule. I'll multiply by this, but I have to turn this into a single thing first, right? and I'm going to have to make the denominators match, turn it into a single fraction, then I can multiply by this. This LCM is a stinker because I cannot add x to this. All I can do is multiply. That's why I like to call this the least common multiple. It's also the least common denominator, but calling it the least common multiple reminds me that the only way I can get this is to multiply these two. Dang. Okay, so this side I'll have to multiply by y over y. This side I have to multiply by x plus y over x plus y. So now I'm going to rewrite this over here. Okay, it's going to be ay plus m times the quantity x plus y. It's getting kind of little, sorry. And then on the bottom, it's x times the quantity, or I'm sorry, it's y times the quantity x plus y. Right? Okay, so now I'm multiplying these, and I'm going to write it down here. It's a lot. It's a plus m plus, no, times, right, because I'm multiplying. So this is a clump, and that's a clump. I'm going to distribute this as I write it, all right, because I don't want to have a clump within a clump. So this is my first clump, a plus m quantity. Now I have ay plus mx plus my, right? I'm distributing as I copy this down here. This is one quantity. This whole thing is a second quantity, right? That's all of this. And I distributed because I don't want a little quantity inside of a big quantity. That's too much drama for me. This, I accidentally put a plus sign here. We're not adding, we're multiplying, right? Because we multiplied top and bottom. We multiplied here and we multiplied here, and then I just copied this chunk over. So I copied my multiplication dot as well. And on the bottom, we have x times y times quantity x plus y. And this is the correct answer. Complex fractions are one thing when we don't have a lot of quantities in them. When we start throwing the quantities in, you know, the parentheses with the adding inside, it gets a little crazier, but our technique is the same. Get a single fraction on the bottom, which so far John's been giving us. Later, there'll be more drama in the denominator. But we take our fraction and we flip it, multiply to get the reciprocal, and then multiply the top as well. And we have been having to do a little bit of simplifying over here before we do the multiplication. There it is. That is the end. And the problems in the practice are exactly like the two problems that we just did. They're exactly like it. So use your notes, if need be, to follow along with these. Okay, thank you. Goodbye.